Okay, we've been learning about solving systems of linear equations. And now we're going to go on and learn about solving systems of linear inequalities. But in order to do that, we need to know how to graph an inequality. So if you've never learned it, or if you need a refresher, grab some graph paper and take some notes and we'll do some together. Write down the inequality y is less than or equal to negative 4x plus 1. What we're going to do here is we're going to graph it just as if it were an equation in slope-intercept form. It's an inequality in slope-intercept form. We can still see that the y-intercept is 1. So we can still plot the point 0, 1 on the graph due to the y-intercept being 1. Then we can still use our slope. It's negative 4 over 1, so let's go down 4 units and to the right 1 unit and plot that next dot. Once we've done that, we can draw a straight line connecting our points, and we're partway there. We've graphed the y is equal to negative 4x plus 1 part. Now we have to graph the y is less than negative 4x plus 1 part. So we're going to need to shade one side of this inequality or the other. We're either going to shade everything on this side of the line, or we're going to shade everything on this side of the line. But which side do we shade? We find that out by picking a test point anywhere on this graph. I like to pick the test point 0, 0 because zeros make for easy math, easy and quick math. But you may pick any point you'd like on this, anywhere on this graph to test to see if it's a part of the inequality. If I pick 0, 0, that means I'm putting a 0 in for y and I'm putting a 0 in for x. I'm substituting 0 for both of those and I'm solving. When I do that, I find that it says 0 is less than or equal to 1. That's a true statement. So because 0 is less than 1 is a true statement, I know that 0, 0, this point here, is a part of the solution set of this inequality. And therefore, when I shade this inequality, I should shade the side that includes 0, 0, since 0, 0 is a part of the solution set. I could pick any point on this side of the line and test it, and every point on this side of the line would be part of the solution set, and it would result in the true answer. So let's shade the left side of this line because of our test point. That's all there is to it. Let's try another one for more practice. Write down y is greater than negative 5x plus 3. And keep in mind, this is not greater than or equal to, it's just greater than, so it's going to look a little different. But we are going to start by finding our y-intercept, which is 3, and plotting the point 0, 3 on the graph, and then finding our slope, which is negative 5 over 1, which means we're going to travel down 5 units, and we're going to travel to the right 1 unit to plot our next point. Once we've plotted that point, we just connect the dots. But instead of making a solid line as if this were an equation, there's no equal to designation at all here. This is not remotely an equation, it's an inequality. So therefore, we can't use a solid line in this case. We have to use a dotted line. So we're going to put the line in the same place, but just make it dotted or dashed instead of a solid line, because we have no reference to anything being equal here. Again, now we need to shade one half of this graph. We have to decide which half of this graph to shade. Do we shade this half of the graph, or do we shade this half of the graph? So again, pick a test point. I'm picking 0, 0 again. Let's plug 0 in for y and 0 in for x and see if we get a true statement. When I substituted 0 in for y and 0 in for x, I ended up finding out that 0 is greater than 1. Now 0 is not greater than 1, and therefore that is a false statement. And because plugging in 0, 0 gave us a false statement, we know that 0, 0 is not a part of the solution set to this inequality. 0, 0 does not solve this inequality, so it will not be shaded. Therefore, we're going to shade the other side of this inequality. Let's try one more. X minus 5y is greater than negative 25. And let's look ahead. First of all, are we going to use a dotted line, a dashed line, or are we going to use a solid line? Well, let's look at the symbol. It's a greater than symbol. It's not greater than or equal to. Therefore, since there's no reference to it being equal, we will not use a solid line. We will use a dotted line or dashed line. Secondly, we can't just look at this equation and decide what our slope and our y-intercept are because it's not in slope-intercept form. It's in standard form. But we know how to get this equation into slope-intercept form. We know that we simply solve for y. And now we'll get this, I said equation, but it's actually an inequality. That will get it into slope-intercept form. So let's go ahead and solve this inequality for y. Let's get y all by itself on one side of the inequality sign. We'll do that by subtracting x from each side. The x's will cancel, leaving me with negative 5y is greater than negative 25 minus x. And then we're going to divide each side by negative 5 to get the y by itself. Now this is where a special rule comes into play. That rule being, if you divide an inequality by a negative number, you must switch the direction of the inequality sign. So because I am dividing this inequality by negative 5, I must switch the sign from greater than to less than. It must face the opposite direction because I divided it by a negative 5. If I were dividing by a positive number, that wouldn't matter. But I'm dividing by a negative number. So remember to switch the direction of your inequality sign. Now it says y is less than 5 plus 1/5 x. Now we have it in slope-intercept form. Our y-intercept is 5. Our slope is 1/5. So let's go ahead and graph this inequality. I'll plot the point 0, 5 to satisfy my y-intercept of 5. And then I will travel down 1 unit. I'm sorry. I will travel up 1 unit. It's not a negative 1, it's a positive 1. I'm traveling up 1 unit and to the right 5 units to plot my next point. And I'm going to connect those 2 points, or 3 or 4, or however many I decide to draw, using my slope, with a dotted line as we discussed before we started this problem, because this is not a greater than or less than or equal to, it's just a less than. Now we decide where to shade, so let's pick our test point. Again, I like the point 0, 0. Pick what you like. And I'm going to plug in 0 for x and 0 for y into my original inequality. When I do that, I end up with 0 is greater than negative 25. Well, guess what? 0 is greater than negative 25. So that is a true statement. That means that the test point I used, 0, 0, is a part of this inequality solution set, and it needs to be included when I shade it in. Therefore, let's shade that 0, 0 side. And that is all there is to it in graphing an inequality. Almost exactly like graphing an equation, with just the part about the dotted line and about the shading being different. So you shouldn't have any trouble acclimating to this. I'm going to give you one to try all by yourself.